In this session today, we're going to be learning about how to find the nth term of quadratic sequences. Now, this comes across originally as quite a difficult concept to understand, but once you understand and just learn a few simple formula, the actual maths behind it isn't particularly difficult. It's just remembering a certain formula. So even if when you're doing this, you don't understand why, that's okay. Because as long as you can just remember the formula, it's going to be enough just to get you through the exams. And at this stage, that's all I assume most of you want. So the formula that you need to think about is this: a n squared plus bn plus c. Now, all that means is that your nth term this time, because it says quadratic, it means that the n is going to be an n squared. There's going to be a number before another n, usually, not always, but usually. And then there's just going to be another number at the end, which is this c. So let's look at the one on the left-hand side here where it says 5, 8, 13, 20. So just like with linear sequences, we try and find the difference between each of these numbers. So the difference between 5 and 8, the difference between the 5 and the 8 there is 3. The difference between 8 and 13, 5, and then 13 and 20 is 7. So that's difficult. We can't, because they're different numbers, we have to use a slightly different technique to what we use with the linear sequences in previous videos. So this time, you then have to find another difference. And this time, you're plussing 2 each time. So the first row, where it says 3, 5, 7, that's called your first difference. So I'll just write diff. And the second one, where it says plus 2, is your second difference. Now, here's the formula that you must try to remember. Okay, so the very top number is a plus b plus c. Now, this a plus b plus c should equal 5. So I'm going to write over here a plus b plus c equals 5. Now, don't worry that this at the moment, I'm aware this will not make sense. It will all come together, I promise. So the next bit, which is this 3 over here, your formula here is 3a plus b equals this. So these are the bits that you just have to learn. So I'll just highlight them sort of pinky purple here for you. And they're always the same for that top row, second row. Now the third row, you have to write as 2a equals this. So if I can now write out all of the formula that we've just created, and we're just looking at the first numbers each time in each row. So the 5, the 3, and then the plus 2. So on the right hand side, you can see I've created a bunch of formulas. Now, the easiest one to do there, because we've only got one unknown in it, is this one. 2a equals 2. So 2a equals 2. To find out what a is, obviously at the moment it's 2 times by a, so we just divide by 2 on each side, which leaves you with a equals 1. Now that is good news, because we now can substitute a equals 1 into the second formula there. So the second formula, which I'll draw a big line from there. So 3a plus b equals 3. We know from here that a equals 1. So it's the same as saying 3 times by 1 plus b equals 3. So 3 plus b equals 3. So we can take away our 3 from both sides, which means that b equals 0. So luckily enough, when we come to our formula up here, b equals 0, which means that there's not going to be something there. That won't always be the case. Sometimes b might be 1, 2, 3, and if b is one of those numbers, then there would be an n. There'd be 1, 2, 3, n, whatever. Okay, so now we've got b equals 0. We've got a equals 11. So now we can substitute that into this one, a plus b plus c. So we know a plus b plus C equals 5. We know from here that A equals 1, so we can just write 1 underneath the A. We know from here that B equals 0, so it's 1 plus 0 plus C equals 5. We can simplify that obviously to 1 plus C equals 5, which leaves you with, if we subtract the 1 from both sides, I'm running out of space here, so I'm just going to draw a line on the right. So it leaves you with C equals 4. So as we've boxed the A equals 1, the B equals 0, C equals 4. So now we need to go back to our formula at the top here, which I've done in this big green box. So every time you see one of those letters, you put in the letters that we've just, or the numbers that we've just found. So A, we figured it out over here, is 1. So it'd be 1 before the n squared. Because it's 1, we know we don't actually need to write anything. So this formula is n squared. Plus B, we discussed that as being 0. So 0n, so nothing there. Plus the C, which is 4. And that's our formula. So as I said earlier, yes, I know that looks complicated, but if you can just remember the formula an squared plus bn plus c is what your sequence is going to look like, your nth term is going to look like, and then the pink boxes over here, then after that, the maths itself isn't difficult, it's just remembering the formula. So good luck, everyone.